All right, section 5.6, graphs of other trig functions. Let's look at y is equal to the cosecant of x. Let's look at drawing a graph of this particular trig function. What we're going to do to draw this is we're going to use y is equal to sine of x. We're going to use this reciprocal function to graph this. All right. Now, I'm just going to show you the shape here. I'm not going to show you how you go through and derive this and so forth. You can do that for yourself if you want to. But let's see what it looks like. Y is equal to cosecant of x. All right. So maybe I'll pick like 2 pi over here. And the halfway mark will be pi. And then split each one of those in half, those intervals. And then we'll come over here and we'll pick negative 2 pi. Halfway is negative pi. Then we have split each one of those in half, okay? And to graph y is equal to sine of x, remember we go up to 1, go down to negative 1. We say the sine function starts at 0, 0, has a period of 2 pi. It goes up, it goes down, but halfway between 0 and 2 pi, it's going to hit the x-axis again. All right, so what happens halfway between this x-intercept and this x-intercept? Takes on its highest point, and halfway between this x-intercept and this x-intercept, it takes on its lowest point. So my sine function does something like this. Now, why am I dashing it? Because that's not actually the function I want. I really want this function. But let me go ahead and label it y is equal to the sine of x. And let me draw this side of it too. Remember, this side is x-intercepts at negative pi, negative 2 pi. And then negative pi over 2 goes through negative 1, and negative 3 pi over 2 goes through positive 1. So it does something like this. It goes on forever in both directions. Now, whenever we draw y is equal to cosecant of x, we're going to use this function here. And everywhere that we have x-intercepts for the sine, so here, 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 and here, we're going to have vertical asymptotes for cosecant. So I'm going to draw those in. I'm going to draw in vertical dashed line for a vertical asymptote. Another one here. Everywhere I have x-intercepts, I'm drawing in these dashes. Vertical dashed line. I have an x-intercept here. I'm drawing a vertical dashed line. X-intercept here. Drawing a vertical dashed line. All right, now, what do I actually want to draw? I drew my sine function. I drew some vertical asymptotes at each one of the x-intercepts. But now I really want my cosecant graph. Now, what my cosecant graph is going to do is that each one of these peaks here and here, or each one of these maximums of your sine function, it's going to be kind of parabola shaped, like it'll look like that. Right here. Going to look like that. And at each one of these minimal values for your sine function, you're going to have something that almost looks like a parabola that goes downward. Remember, it doesn't touch these vertical asymptotes, just kind of hovers along them. And let's label these x-intercepts. All right, so this x-intercept is what? Pi over 2 comma 1. This x-intercept right here is 3 pi over 2 negative 1. This x-intercept, why am I saying x-intercepts? That's not x-intercepts, that's points. Okay, this point on my cosecant graph is going to be negative pi over 2 comma negative 1. And this point on my cosecant graph is going to be negative 3 pi over 2 positive 1. So this in purple is what the graph of y is equal to cosecant of x looks like. It's bound between each one of these vertical asymptotes here. And it goes up, goes down, goes up, goes down. It keeps repeating itself, okay? And we say it also has a period of 2 pi. So whenever it goes one complete U up and one complete U down, that's a period, 2 pi. All right, let's talk about the vertical asymptotes and the x-intercepts. So you're going to have x-intercepts, and where are they going to appear? Well, this one doesn't have any x-intercepts, right? So I'm going to say none. What about vertical asymptotes? Where do those things appear? They appear at negative pi, 0, pi, 2 pi. So they appear at n times pi, where n is an integer, where n is an integer. Actually, what I need here is I need x is equal to, because the vertical asymptote has an equation, x is equal to n times pi. All right, so that's the graph of cosecant function. I want y'all to memorize how you draw that. Okay? Let's look next at y is equal to the secant of x. Y is equal to the secant of x. Erase all this stuff. Y is equal to secant of x. And this one's going to be very similar to the last one. Okay, we're going to use to draw this is reciprocal function. Y is equal to cosine of x. Let's draw the cosine of x with dashed lines. Now, what does that thing look like again, the cosine of x? Well, we could say, okay, here's 2 pi, here's pi. Draw tick marks halfway between each one. Over here, here's negative 2 pi. Here's negative pi. We'll draw tick marks in between each one of them. We'll put 1. We'll put negative 1 on the y-axis. All right, cosine. From 0 to 2 pi, it's going to start here, and it's going to end right here. Halfway between 0 and 2 pi, which is pi, it's going to hit its lowest point. And halfway between the highest and lowest point, it's going to be the x-intercepts. And if I draw this with a dashed line, I get something that looks like this right here. Y is equal to cosine of x. Now let's complete the other side. Over 2 pi, it's going to be back up here. Halfway between 0 and negative 2 pi, it's going to take on its lowest point. Halfway between lowest and highest, x-intercept. So it's going to look something like that. All right, just like the last example we did, everywhere this cosine has an x-intercept, we're going to have vertical asymptotes. So we're going to have one right here. We're going to have one right here. We're going to have one right here. And we're going to have one right here. All right, just like last time, at the maximum, you're going to draw a U shape. The minimum, you're going to draw U shapes. Okay, so right here, we're going to have kind of like a U shape coming down. Like that. Right here, you're going to have this shape again. Now notice you don't touch or cross your asymptotes. At this maximum right here, you can have a U shape that curves upward. And here you're going to have some more U shapes. And I'm just going really to negative 2 pi. Technically you have another U shape here, but I'm only showing it here. So I'm just going to draw that likewise right here. All right, let's label some points. This point right here is going to be negative pi, negative 1. This point is going to be 0, 1. This point is going to be pi, negative 1. What would this point be? 2 pi, 1. And this one would be negative 2 pi, 1. Now, same thing with the cosine. It has a period of 2 pi, and the secant also has a period of 2 pi. And we have one complete period whenever we get a whole up and then a whole down portion of it. So from here to here. Well, what is that? That's from negative pi over 2 to what? 3 pi over 2? So how far is that for negative pi over 2 to 3 pi over 2? Well, this would be from 0 to here would be 3 pi over 2. Plus another pi over 2 be what? 4 pi over 2. What's 4 pi over 2? 2 pi. All right, what are my x-intercepts here? Remember, we're looking at secant. We're looking at the purple one here. One that's not dashed. I have none. It never crosses the x-axis or touches it. But where are my vertical asymptotes at? Remember, it's always going to be x is equal to something, okay? Now, what is it? It's at pi over 2. It's at 3 pi over 2. It's at negative pi over 2. Negative 3 pi over 2. So as you can see, we have some kind of pi over 2, and it's always odd numbers up top. So I'm going to say 2n plus 1 times pi over 2, where n is an integer. Where n is an integer. N is an integer. All right, so know how to draw this, know the shape of the secant graph. How do you draw that again? You draw it using its reciprocal function.